Welcome to Low-Level Programming Crashcasts. I'm Sheila, and I'm here with Victor to dive into the fascinating world of low-level programming. Before we begin, if you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. Your support means the world to us.
Thanks, Sheila. We're excited to kick off our new season on Introduction to Low-Level Programming. Today, we're starting with the first chapter, Understanding Computer Architecture, and our focus will be on the basics of computer organization.
That's right, Victor. And to get our listeners' gears turning, I've got a quiz question for them. Here it is. What was the name of the first general-purpose electronic computer developed in the 1940s?
Ooh, that's a great question, Sheila. It really takes us back to the roots of computing. I'm sure our listeners will be intrigued to learn about the early days of computer development. It's fascinating to think about how far we've come since then.
Absolutely. Now, before we dive in, let's clarify a few key terms. Victor, could you explain what we mean by computer organization in the context of low-level programming?
Certainly. Computer organization refers to the way the various components of a computer system are arranged and how they interact with each other. It's essentially the blueprint of how a computer is built and operates at a fundamental level.
That's a great explanation. So, if we think of a computer as a complex machine, computer organization would be like understanding its anatomy, right?
Exactly. That's a perfect analogy. Just like how understanding human anatomy is crucial for doctors, understanding computer organization is essential for low-level programmers.
Now let's start with the basics. What are the main components of a computer system?
At its core, a computer system consists of three main components: the central processing unit, CPU, memory, and input-output, I/O devices. The CPU is like the brain of the computer, performing calculations and making decisions. Memory stores data and instructions, while I/O devices allow the computer to communicate with the outside world.
That makes sense. So, if we were to use a kitchen analogy, would the CPU be like the chef, memory like the ingredients and recipe book, and I/O devices like the various kitchen tools and appliances?
That's a clever analogy, Sheila. Yes, you could think of it that way. The chef, CPU, reads the recipe, instructions, from the recipe book, memory, uses ingredients, data, stored in the pantry, also memory, and interacts with kitchen tools, I/O devices, to prepare the meal, execute the program.
I love that. It really helps visualize the concept. Now, I've heard the term von Neumann architecture mentioned a lot when discussing computer organization. What exactly is that?
The von Neumann architecture is a fundamental concept in computer organization, named after the mathematician and physicist John von Neumann. It describes a design where both data and instructions are stored in the same memory. This architecture introduced the idea of a stored program computer, where the program's instructions are treated as data that can be modified.
That sounds revolutionary. How does this architecture work in practice?
Well, it operates on what we call the fetch-decode-execute cycle. The CPU fetches an instruction from memory, decodes it to understand what operation to perform, and then executes that instruction. This cycle repeats continuously as the computer runs programs.
Fascinating. So, if we go back to our kitchen analogy, would this be like the chef reading a step from the recipe, understanding what it means, and then performing that step?
Exactly. And just like a chef might modify a recipe as they cook, the von Neumann architecture allows programs to modify themselves, which is a powerful feature.
That's really interesting. Now, I'm curious about how these components interact with each other. Could you elaborate on that?
Of course, the interactions between components are crucial to the functioning of a computer. The CPU communicates with memory to fetch instructions and data, and with I/O devices to receive input or send output. This communication happens via a system of interconnected wires called a bus.
A bus? Like a vehicle that transports people?
Similar concept, but in this case, it's transporting data. Think of it as the roads connecting different parts of a city. Just as roads allow people and goods to move between locations, The bus allows data to move between the CPU, memory, and I/O devices.
That's a great way to visualize it. Now, are there any common misunderstandings about computer organization that our listeners should be aware of?
One common misconception is that the CPU does everything in a computer. While the CPU is crucial, it's just one part of the system. The interplay between all components is what makes a computer function effectively.
That's a great point. It reminds me of how a kitchen needs more than just a chef to run smoothly. Now, before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The first general-purpose electronic computer, developed in the 1940s, was called ENIAC, which stands for Electronic Numerical Integrator and Computer. It was a massive machine, weighing about 30 tons and occupying a large room.
Wow, that's incredible. We've certainly come a long way since then. To summarize today's episode, we've covered the basics of computer organization, including the main components of a computer system, CPU, memory, and I/O devices, the von Neumann architecture, and the fetch-decode-execute cycle. We've also discussed how these components interact through the bus system.
Absolutely, Sheila. Understanding these fundamentals is crucial for anyone diving into low-level programming. It provides the foundation for everything else we'll be discussing in this season.
Thank you, Victor, for these insights. And thank you, listeners, for joining us today. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Don't forget to subscribe and rate our podcast. Your support helps us continue creating content that demystifies low-level programming. Until next time, happy coding.